Okay, we're recording. Here are the notes that you just did with the PowerPoint. Let's go down to the bottom. Pause if you need to copy any of this down. Okay, I'm moving on. Bye. Get out of the way. There we go. No more. All right, let me zoom in here. Okay. Now we're going to classify them in this table here. First of all, let me let you know, everything we use in 6th grade are rational numbers. Now, think about the number 5. Can I write it as an integer? I'm sorry, as a fraction? Yes, I can write it as a fraction. I just put 5 over 1. Doesn't that still equal 5? Yeah, then it's a rational number. 1 1/2, if I Texas two-step that, you'll learn that soon. 2 times 1 is 2 plus 1 more is 3. So 1 1/2 is 3 halves. So I can write it in A over B form. Negative 0.5, well, that's just negative half, because 0.5 is 5/10, and 5 out of 10 is 1/2. Negative 3 would be negative 3 over 1. 0, could I put 0 divided by 1? Yes. If I have nothing and I divide it to myself, the answer is still 0, but it's in fraction form. Okay, 17.0, I would drop the 0, and that gives me 17 over 1, and 7/5 is already A over B form. So any number you can write with a numerator and a denominator is a rational number. So, like I said, everything in 6th grade is a rational number. Okay, let's start. Is 5 a natural number? Can you count to 5? I hope so. So that means it's in the inside little purple circle. So if it's in the little purple circle, that means it's inside every circle. It's in all of them. Okay, 1 1/2. Do we count that way? No. Is it a whole number? It has a whole number, but it also has a fraction, so that makes it not a whole number or an integer. Because it's got that 1/2, it's just a rational number. Okay? Just same thing with the negative 0.5. Just because it's a negative doesn't mean it's an integer. That 0.5 keeps it out of every circle or box except for rational numbers. Okay, what about negative 3? Do we count to negative 3? No. Is negative 3 a whole number? No. Is it an integer? Yes. Negative 3 is in the integer circle. Okay, 0, haha. We just discovered 0 is not a natural number. We don't count with it, but it is a whole number, which means it's also inside the integer and the rational. Now, can we count to 17? I hope so. 17 is natural, whole, and integer. So if it's in the natural, it's in everything. Okay, 7 over 5, that's 7 divided by 5. And if I were to work this out, 7 divided by 5, that equals 1 whole. And then I'm going to have 2/5 left over. Or if you use a decimal, it would be 1.4. Not natural, not whole, not integer. Because of the 2/5, it's only a rational number. All right, let's flip it over. Oh, there's the little nesting dolls, one inside of another. They've escaped. Okay, use the diagram to complete the questions below. Let's see, we got natural numbers here. 35 divided by 7, that equals 5. 5's a natural number I can count to. 30.0, I can drop the 0.0. It's a natural number. There was nothing in the whole numbers. Integers, it says negative 10 divided by 2. Well, 10 divided by 2 is 5, and a negative 10 divided by 2 would give us negative 5. And then 37.5, because of the decimal there, it stays in the rational numbers. Okay, number 1. Which number belongs only in the integers and rational set? So it can only be in here or here. Negative 9 can be an integer. I'm going to put that here. Is it in both circles? Yes. 75 would go in the natural numbers. No, that's not it. Negative 10.2, that's only rational number because of the 0.2. Negative 8 divided by 5, well, 5 will fit inside of 8 one time with 3/5 left over. Because of the fraction, It's rational only. So what fits in the integer and rational? That would be A. Okay, number 2. Scoot it up just a little bit. Why does 30.0 belong in the natural set? Is it because 30.0 is equal to 30? Maybe. Is it because 30.0 is equal to 3? No. Is it because 30.0 is equal to 0.3? No. Is 30.0 does not belong in the natural set because nobody on this planet can count to 30? That's wrong too. The 0.0 can drop off, and then that just gives you 30, which is a natural number. A. All right, moving on down. A little bit more of guided practice, and then you'll be on your own. Okay, classifying. -15, I would not put that in rationals, but that does belong in integers because it's a negative, and it's got like a whole number, but there's no decimals or fractions with it. So that belongs in integers, which means it's inside integers, and it's inside rational. It's inside both of these boxes, not in the whole or the natural. Okay, 2 and 5/6. Because of the fraction, it will only go in the rational numbers. Let me put it here, 2 and 5/6. All right, 0.8, because of the 0.8, can't drop that off. Rational only. Oh, look at them trying to sneak in an absolute value of 5. What is the absolute value of 5? Well, that would be 5. So 5 is a natural number, which means it's also inside the whole numbers, which means it's also an integer. And everything we do is rational. Well, almost everything I do is rational. All right, absolute value of 5 goes inside the natural numbers. Okay, let's see. -12 divided by 2. Well, let me solve this. It would be a negative, and 12 divided by 2 is 6. Not a counting number, not a whole number, but it is an integer, and it is a rational number. So I'm going to put it with my integers, -12 divided by 2, because the value of that is 6. Okay, next up, you have this independent practice assignment. It will be a grade in Schoology. So once you finish the paper, please enter your answers in Schoology. I hope it's published. And then just be careful as you're reading this. Like number 1, with all these numbers in the diagram there, in the nested Venn diagram that are classified, which ones are incorrectly classified? So look through here, find them on there, and see who's incorrect. Okay. Number 2. This looks familiar. Check all the number sets in which it belongs. So all of these numbers, be careful your absolute values, and if it's improper, then go ahead and divide it. Okay, next one, number 3. You're going to place all of these numbers into the nested Venn diagram. So you're going to write them inside here, and I believe in Schoology it'll be a click and drag. Okay, on the back side. Okay, this one's fun. Set A represents rational numbers. So on the set A, I put an R next to all the A's. So that reminds me, those are rational, 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 rational. Set B are integers. So by the set B, I put an I. Now what they want to know is which of the numbers are placed correctly. Are these rationals? Are these integers? Are these rationals? Integers? Are these rationals, integers, rationals, integers? Which one is correct? And finally, number 5. In our nesting Venn diagram, which one of these represents the relationship among rational numbers, integers, and whole numbers? Okay, they didn't put natural numbers in there. Sometimes they leave them out. Just pick which one you think is correct. Okay, have a great rest of your day, and don't forget to submit in Schoology for a grade. Bye.